under motion on an inclined plane. Now take down please. Take down please. To solve problems involving motion on an inclined plane. To solve problems involving motion on an inclined plane, note the following. Number one, note the following please. Number one, when a body of mass m rests on a rough surface, when a body of mass m rests on a surface as shown below, you can now draw this. When a body of mass m rests on a surface as shown below, you can now draw this. Sketch, are we done? Two forces act on the body. Two forces act on the body. Two forces act on the body. Number one, two forces act on the body. Number one, the weight of the body. Number one, the weight of the body acting downwards. Number one, the weight of the body acting downwards. Number one, the weight of the body acting downwards. Alright, so here's your first note when it comes to dynamics planes. We're drawing free body diagrams, right? Before we do free body diagrams, let's understand different scenarios of bodies. Now your first concept is this. If I have a body like this, of course, rest on the surface here, what force or what forces act on this? The first one there is the weight. And please take note, please. Weight always acts vertically downwards. Now next up, if you use the idea of Newton's law of motion, and then by the way please, weight is equal to mass times gravity. Please don't forget that please. Weight is equal to mass times gravity. Now next up please, if you use Newton's law of motion, the third law, it says that the word there, to every what? Action, there's what? An opposite and what? Equal and opposite reaction. That means to this force here acting downwards, there must be something opposite to this. What that is called the normal reaction. So I have this. I can call this N. So for a body resting on the plane surface, there are two forces there. Number one, the weight acting downward. Number two, normal reaction acting what there? Upwards. Don't forget this. Don't forget this. Alright, so here's your first concept. Number two, so first concept, body on rough surface, two forces, weight downward, normal reaction upwards. Next up please. If a body is placed on an inclined plane, if a body is placed on an inclined plane, the forces acting on it are shown below. If a body is placed on an inclined plane, the forces acting on it are shown below. Alright, look at this. So let's call here theta. Look up, please. Let's call your tutor. Now look up, please. Listen. Here's what to note about inclined plane. Listen. Number one, look up, please. Number one, we said if I look at this case here, I'm seeing body, I'm seeing weight acting downwards. Now normally you would think that if I take this one here and place it this way, just as this is coming down like this, you would expect that this weight should have come this way like this. Of course, to look like this way here. Of course, just to look like this. So this is what you would expect. But this is not the reality, please. In reality, weight always acts vertically downward. So even when a body is placed on an inclined plane there, the weight will always act this way. I'm having weight is equal to what? M times G. So I have this place. So please, take note please. For a body on inclined plane, you'd expect that the weight will act down, like this way now, but it doesn't act that way. It acts this way, vertically downward. Now hang on please. Look up please. Hang on please. Now here's what's next. Look up please. Here's what's next please. Note that the force that makes this body slide either downward or upward on an inclined plane is given by mg sine theta. Please note this please. The one that makes this body move this way is given by mg sine theta. If this is sine theta, now hang on, the idea is this. I'm resolving this weight here into horizontal and vertical component. Of course, if this one gets mg sine theta, this one becomes mg cos theta. So I'm having this thing. So here's what you should note, please. Look up. Here's what you should note, please. Note that the force responsible for a body sliding this way is always mg sine theta. That's side of this angle. Please take note. Also, weight is not acting this way, as in this case, it acts vertically downward. So resolve the weight this way, it becomes mg cos theta. Of course, from here, normal reaction going upwards. This way, I have, of course, and here. Right. So you have this place. So what's your pick there? Number one, weight to act downward. Number two, force responsible for this motion here is mg sine theta. I think these are like the two most important. And then you have n here. N here. Get these differences. Get these differences, please. When a body, look at this. Get these differences, please. When a body is on a smooth surface or just a place like this, you have that normal reaction N, of course, is equal to weight here, W, is equal to mass times gravity. That's for this case. Case 2, when a body is inclined at an angle to this, an inclined plane, you have that normal reaction N is equal to no longer W, but what there? Mg cos theta. That's Mg cos theta. Please see the difference, please. For here it's just Mg, for here it's Mg cos theta. Please get these two differences. Alright, let's get an example. I think alright, take down. Something else to add to this. Take down. Note that from Newton's second law of motion, we have that force F is equal to mass times acceleration. That's from Newton's second law of motion. Take down, if you're done. For multiple forces, Newton's law of motion, or Newton's second law, can be stated that the sum of forces is equal to MA, that's all. So if it's a single force equal to MA. If it's a number of forces, then the sum of the forces is equal to MA. I think that's about everything there. Equal to MA. Example 1. Given two bodies of masses M1 and M2. Please, M1 is M subscript 1 and M2. That's N subscript 2. As shown below. Are we there? Derive an expression for the acceleration of the system. So we'll take this for a practice, right? But let me give you the concept. Look at this. Now, here's how it works. Look at this. When it comes to analyzing a system like this, what's the first thing you do? That's the question. What's the first thing you do? The first thing you do is for you to look at the greater mass. Look at the greater mass. The idea is this: the system will move in the direction of what there? The greater mass. Now try to imagine, look at this. Try to imagine here, I have this inclined plane, and at this point here, I tie a stone. Right? You have a stone here, you tie a stone here, pass the thread all this way then, and then tie a feather. So at this point here, I have a stone, at this point I have a feather. Question: if I move my hand, in what direction will it go? Will it go this way, A, and B this way, B? Which of them? A. It will go in the direction of what there? A. That's the concept. So your first task is to always identify what there? The greater mass. The idea is that the motion will always go in what there? The direction of what? The greater mass. Alright. So that means in this diagram, we are assuming that M2, this one, is a greater mass to this. That means M2 is greater than M1. That's the first task. Alright. If you're done with that, what next? Get out your free body diagram. Get out your free body diagram. Take that, please. Notice somewhere, please. A free body diagram is, so when we say get out free body diagram, what do we mean? Let's define terms. A free body diagram is a diagram that shows all the forces acting on a body at a particular point and time. A free body diagram is a diagram that shows all the forces acting on a body at a particular point and time. Full stop, that's all. Having said so, look at what's next. Now listen, please, let me try to analyze it. Look at it. If it comes to drawing free body diagram, how do I get free body diagram? Now, here's your first concept. Look at, here's the first concept. Let's have this one here. Let's have this one here. So this becomes M2. So for M2, what do I get? Your first task is this. We said when a body is lying on a surface as of this nature, we said this is M. What access what there? Weight, have it? Which equal to what there? Mg. The same concept lies here. So what will act here is this one coming down here. Now notice, in this diagram I have two masses, M1 and M2. So what will act in here is no longer Mg, but what there? M2G. Specify the mass. M2G acting downwards. So what's next? Look at this. Look up. Let's take an assumption. Look at this. Let's bring in the idea of tension. Listen. Let's bring in the idea of tension. What's a tension? A tension is simply a force acting on a string. That's all. Right? A force that acts on either a string or a rope is called tension. That's all. Now, here's what to note. Look at this. Here's what to note. Imagine, look at this. Imagine this now. Look at this now. Look at this, please. I have a piece of chalk here. If I let go of this chalk here, it falls. True of us? Now, get a second assumption. What if I tie a string to this? Look at this. What if I tie a rope to this now, and I hold the rope to this? Will this fall? No. It will not fall. Now, what does it mean? Look at this. If I don't tie a string, it will fall which way? Downward. There's something about what is called frictional force. We said frictional force does what there? Opposes motion. But that's one concept. A second concept is this. Frictional force acts in what direction? Is it in the same direction as the motion of the body or opposite direction? Opposite direction. So here's now the idea. If I leave this now, this will fall. If I tie a string to this and hold this now, it will no longer fall. Now, if it's not falling, what does it mean? It means that there's a force acting what there in the opposite direction to what? This one here. And what force is that? Is the force on what? The string, aka what there? Tension. That means in this body here, while this is acting downward, tension will act what there? Upwards. Please. Why is tension acting upwards? Because it is retarding its motion. If I tie string here, it will no longer move. Now that's case one. Look at it, please. A second concept is this, please. The string that you have from here to this point, is it the same string? Yes. Huh? Yeah, the same string. Look at this, please. Look up. Now, listen to this one. I said if I have a stone and a feather here, it will move this way. Now, try to imagine, look at this. Try to imagine now, if I cut off this rope, if I cut this one off, this M1 here, how will it move? Will it move this way, that's A, or this way, B? If I cut off this string, where will it move? It will go this direction. Hence, for this body here, the main direction is this one here. Assuming it's not influenced by this. And we said when a body is inclined at an angle, what I showed you earlier, the force here acting becomes what there? Mg sine theta. But in this case, it becomes what there? M1 instead. So this one becomes what there? M1g sine theta. So are we good? If I'm having M1g sine theta, picture these two things. If I cut off this string, this one will fall this way. But if I hold it here, will it fall? What the force acting here is your tension. So for the fact that this tension can retard or can stop the motion of this body, what does it mean? It means the tension acts what there? Opposite direction. So I have this tension. So that's all about that. That's what you should know, please. Number one, weight coming this way here, tension will act in opposite direction. Number two, this one here, normally it should fall this way. Look for tension. It comes this way. No question. So look at this. If you're done with this, what next? Start with the in quotes, leading mass. Please. For M1, M2, which was greater? M2. We said M2 is greater. So let's start with M2. For mass M2, what do we get? Look at it. First of all, let's get the sum of forces. The sum of F2, that's the force on mass M2, is equal to, how do you get the sum of forces? Listen, it's as easy as this. Listen, if that particular force is going in the direction of that motion, it is considered positive. If that particular force is going in the opposite direction, it's considered what there? Negative. For mass M1 or M2, please. Sorry, please. Before this, please. For mass M2, let's check this out, please. This becomes M2. So I'm having this one here. We call this M2. We said it's coming down here. This is M2G. That's just this one here. The one going up is what there? Is T. Question is, let's get sum of F2, the force. Alright, for some of the forces, please. Let's look at it. Let's call this A, let's call this B. we said this one is moving this way, down, it's coming this way, it's going downwards. Please, M2G, if you look at this now, M2G is going in the same direction as before, true of us? So it becomes what there? Positive. So it becomes M2G. Next up, I have T. T is going in the same direction or opposite direction. So it becomes what there? Minus T. That's all. That's all. This body is falling this way. This one is going in the same direction as before. Positive. This one is going in the opposite direction. Negative. That's all. So we said but we said sum of forces is equal to MA. In this condition here, considering M2, I have that the sum of F2 is equal to what there? M2A. When is F? Is MA. When is F2 becomes what there? M2A. No big deal. What is this value? This value is this, so becomes what there? M2G minus T is equal to what there? M2A. Call this equation 1. So I'm done with mass 1, please. Right? M2G minus T. Sum of forces equal to MA. We said so I'm having this. We are done with mass M2. Let's look at for mass M1. Let's look at for mass M1. So look at me. Look up. So here's my M1. So I'm having this one here. We are calling this M1. For M1, we have two forces. This one going down, M1G sin theta. So I have this one going down here. M1G sin theta. You have this one going upward there. It becomes what? T. So I have T upwards. You can see here. I have M1G sin theta downward. Alright, let's get sum of forces. Since this was F2, it became sum of force 2. I'm having M1 here, so it becomes what there? Sum of F1 is equal to, how do you do sum of forces? The idea is simple. Any force going in the direction of that motion becomes what there? Positive. So come back to this diagram now. How is this moving? We said it's going this way. So let me bring this concept here. It's actually moving this way. It's actually moving this way. So if I look at this page, you can see that T is going in this direction a bit. So from this now, it becomes F1 is equal to T in that direction. Obviously, you can see this one going what there? Opposite direction. So it becomes what there? Negative. So it becomes minus M1G sin theta. Alright. Alright, so look at this. Look at this. So the same concept here, but we said the sum of forces is equal to what there? MA. Write this now in terms of F1. It means that the sum of F1 is equal to what there? M1 times what there? A. Input the value of F1. F1 is this. So replace this becomes what? V minus M1G sin theta is equal to what there? M1A. Call this equation what there? 2. So I now have two equations. Equation 1 and equation 2. Please, you have to find what, please? Expression for what? For acceleration. Look at this. How do you get expression for acceleration? Look at this. Now, here's how it's done. For this one, you're having just two equations. Some you have 3 equations, some you have 4 equations. But how do you work on it? Look at, the idea is this. These two tensions are said to be the same. So it means that from any of the equations here, make T subject of the formula. Let's use equation 2. From equation 2, let's make T. From equation 2, let's make T subject of the formula. From here, t is equal to negative. Constant becomes what there? Positive. So it's equal to m1a minus becomes what there? Plus m1g sine theta. So here's the value of t from here. Must I always use equation to know whether 1 or 2, use any one, at the end we'll have the same answer. You now put this value, put t, this value into the other equation, into equation 1. So look at this. Look at, if I put t into 1, from equation 1, or from 1, I had this one here, that's m2g minus t equal to m2a. Put the value of 2 here, of t here, it becomes m2g minus t. Please, personal advice, put t in brackets. T is this value, it becomes minus t is m1a, that's this, plus m1g sine theta. So it becomes m2g minus t is this, is equal to what there? m2a. Alright, expand. Let's see how this goes. This becomes m2g, this and this, minus m1a minus plus minus m1g sine theta is equal to m2a. Since I want to get acceleration, move all the terms containing a acceleration to one side. So hence, I'll move this man over here. This now becomes m2g. I'll move this one here. So repeat this one, it becomes minus m1g sine theta is equal to, I have this, m2a. Minus comes and becomes what there? Plus m1a. So I have this. Next up, factorize a out of this. I'll have m2g minus m1g sine theta is equal to, take out a from here. You're left with what here? m2 plus m1 all into a. So a times m2, m2a plus a times m1, m1a. So I have this. So this is on factorization. Let's make a. Alright. So let's make a subject to the formula here. Of course, I will divide both sides by what? Divide by m2 plus what? Now listen. Divide by this coefficient there, m2 plus m1. Look at this. Alright. This now becomes m2g minus m1g sine theta equal to m2 plus m1a. Divide this by m2 plus m1. Divide this by m2 plus m1. From here now, this cancels this. So it means that acceleration A is equal to m2g minus m1g sine theta all over. I'm trying to flip this, so it becomes m1 plus m2. You can say m2 plus m1, same thing. This now becomes what I was asking for. That becomes the acceleration of the system. So that's how you find acceleration.